Hello and welcome back. We are looking at higher maths trigonometric expressions. Today we are looking at the wave function. So in the last video we looked at what happens if we add some sine and cosine waves together, and if we do we get a beautiful wave that can be written as a sine or cosine wave. So here we are doing root 3 cos x minus sine x, and we get this beautiful smooth wave that can be written as a sine wave or a cosine wave that has been stretched vertically and moved left or right by a certain amount of degrees. So today we're going to have a look and find out how to find out the amplitude and the horizontal shift. So express root 3 cos x minus sine x in this form. So first thing to do, let's have a quick look at what it looks like. So it looks like a cosine wave that's been stretched to a height of 2, so it has an amplitude of 2, and it's also, rather than starting at 0, 1, it's also been moved 30 degrees to the left. So it's a cosine wave that's been stretched by a height of 2 and has been moved 30 degrees to the left. So let's have a look at finding out how to calculate those values for the amplitude and the horizontal shift, or the phase shift as we could call it. So express root 3 cos x minus sine x in this form. So the first thing we do is you write down root 3 cos x minus sine x equals k cos x minus alpha. We then expand cos of x minus alpha using the addition formula, and then multiply through by k. Now we need to state that to get our first mark in any assessment we would ever do. Okay. To help you, you don't need to do this, but I would reorder these two. So we're just multiplying three terms here, so it's okay to write k cos alpha cos x, and here k sine alpha sine x. So for our next mark, we need to equate cos x. How many cos x is on both sides? Well, here I've got root 3 multiplied by cos x. On this side of the equal sign, I have k multiplied by cos alpha multiplied by cos x. So that means that k cos alpha must equal root 3, because these are equal. We have to have the same amount of cos x's on both sides. In a similar way for sine x, so I've just put them in a little cloud here if you're wondering what I'm doing, k sine alpha will be negative 1. We've got a minus sign there, so k sine alpha is negative 1. So I must state that explicitly as well, guys. So it's k cos alpha, not k cos x. It's k cos alpha that equals root 3, because we have root 3 cos x there. We have k cos alpha cos x here. So k cos alpha is root 3. Now the next step, so what we've essentially done is this step and this step. Next step is to find k. The value of k is just the square root of a squared plus b squared, where a and b are just these two values here. So I'm going to square root 3, I'm going to square negative 1, I'm going to add them together, which will be 4, then square root to get 2. That's our value of k done. That's mark 3. And then mark 4, find alpha. So we can use tan alpha as k sine alpha over k cos alpha, and the k's will simplify. So k sine alpha is negative 1, k cos alpha is root 3, so tan alpha will be negative 1 over root 3. Now the inverse tan of 1 over root 3, as you guys will all know, is 30 degrees. So we need to use a cast diagram here to find out if we're looking in the second or the fourth quadrant, because tan is negative. So we know k sine alpha is negative. So sine of alpha is negative, so we can't be looking in the first or the second. So our answer's either got to be in the third or the fourth quadrant. K cos alpha is positive, so our answer's got to be in the first or the fourth. So it must be in the first or the fourth. It must also be in the third or the fourth. So that means it's got to be in the fourth. So we're looking for the answer in the fourth quadrant. So inverse tan of 1 over root 3 is 30 degrees. We're looking in the fourth quadrant, so it'll be 360 minus 30 degrees, which is 330 degrees. Okay, so, and we're asked to write it in the form k cos x minus alpha. Well, k is 2, alpha is 330. So root 3 cos x minus sine x is 2 cos bracket x minus 330 close bracket degrees.